Our next contestant is Brandon Quintana. Brandon is earning an MS in biological science, and the title of his presentation is Friend or Foe? Effect of eelgrass on biomass and condition index in a multi-habit living shoreline. Brandon, would you turn on your camera and microphone and say hello?
Hello, everyone.
Great, we can hear you, Brandon. So are you ready to get started?
Of course.
All right, here we go.
So, do you ever hit a wall, or should I say seawall? If you're a wave, you probably hit seawalls often. They're one of the man-made coastal infrastructures across California made to combat coastal degradation, but at what cost? In the long term, they break down, increase erosion, and decrease habitat. What if I told you there was an alternative to shoreline protection? Living shorelines are that alternative, and they're made up of natural resources and placed strategically to decrease erosion and increase habitat. This living shoreline in Newport Bay on the left consists of restored native oysters and eelgrass, where both populations have severely declined, and restore them while creating habitat for other species. My work is focused on investigating the relationship between oysters and eelgrass and finding out whether they are friends or foes. To test this, I use two response variables, biomass and condition index. Biomass provides an estimate of how much ecosystem services can be expected to be returned. For instance, the higher the biomass, the more filtration function we can expect to be offered. On the top right, we have two oyster beds, one that has a higher total biomass that provides more filtration services versus on the right, we see a sparse oyster bed, which has a lower biomass and is lacking in its filtration services. Condition index provides important biological information on how the species is doing at the individual level and is basically a summary of the health of the organism. So let's pull two oysters out of our reef. Our plump oyster on the left side has a high condition index and would be considered healthy versus the emaciated oyster would have a low condition index and be considered unhealthy. We are going to use biomass and condition index together to understand the ecosystem services being returned and the health of the organisms there in order to see the small and the big picture in Newport Bay and inform future management decisions. So far, we have found that some ecosystem services, like water filtration, were significantly reduced when eelgrass was present, but also learned that eelgrass, when it was present, there were significant increases in biodiversity, eelgrass growth, sedimentation, and decreases in the wave energy coming in. The takeaway for this talk is that learning more about this specific coastal restoration approach can immediately inform co-restoration efforts and answer the question, are oysters and eelgrass friends or foes? Like some relationships, it's complicated. And it really depends on what the goals of your restoration project are. And once those goals are decided, we can better restore species and habitat and ultimately better protect coastal communities depending on our coastline, which is particularly important in the face of climate change and sea level rise. Thank you.